In this exercise, we're asked to use the null and alternative hypothesis chosen and the test statistic calculated to determine the p-value. So I'm looking at this part right here. Well, first of all, I want to take a look at my null and alternative hypothesis chosen. I want to notice that I have chosen to do a right-tailed test. This is a right-tailed test. Sorry, my stylus is not working well, because my alternative hypothesis has a greater than sign in it. So we got a test statistic of 0.31. That's like a z-score. And sorry, this is a t-score. And in this case, this is a t-score because I notice that we are in the t-distribution because we are using our sample standard deviation as an approximation of the population standard deviation. S is the standard deviation of a sample, and we are using it to approximate the standard deviation of our population. Anytime you are dealing with a hypothesis test for means and you are using S as a substitute or approximation for sigma, you are now in the t distribution as opposed to the normal distribution. So we look at this, and with t distributions we need to identify our degrees of freedom. Well, degrees of freedom is always one less than the sample size, and so in our case that would be 1 less than 26, which gives me 25 degrees of freedom. Now, if you go to your table of critical values for the t distribution, you do not have the option to find the t or the p-value. You can only go and identify, okay, I've got 25 degrees of freedom, and I am given a level of significance of 0.01, and that's the area in one tail since we're doing a one-tailed test. And so we go to the column with a 0.01 in the one tail and down to 25 degrees of freedom, and we can get a critical value of 2.485. What that tells us is that if our test statistic is out beyond that in the t distribution, then we would reject the null. Well, let's picture this. T distribution looks like the normal curve in that it's very bell-shaped, but it's typically flatter in the middle and fatter in the tails, especially with smaller degrees of freedom. But what we've identified is with a significance level of 0.01, then in the t distribution with 25 degrees of freedom, you would have to go out 2.485 standard deviations from the center of that distribution to get 1% out beyond it. Well, we clearly aren't anywhere near that. Our test statistic is within 1 standard deviation of the mean, and so the area out beyond our test statistic is much larger than 0.01. Now, the only means, though, that we have of finding the p-value here is to use technology. And if you have a TI-83 or a TI-84 calculator, you can use your tcdf command. With tcdf, you basically give lower boundary, upper boundary, and degrees of freedom. My stylus is not working well, so my lower boundary would be my test statistic, 0.31. My upper boundary would be positive infinity, like something like 10,000, and then comma 25 for my degrees of freedom. And that gives me, when I round to 3 digits after the decimal point, that gives me a p-value of 0.380. Now, clearly, P is not low, so we do not reject the hoe, which is why option B is the correct answer. We fail to reject the hoe. There is not enough evidence to support the claim. Remember, we have enough evidence when we reject. We do not have enough evidence when we fail to reject.